This section of the chapter is on solution concentrations. So we're going to learn about that. Let's first, what do you think the word concentration means? Okay, when you think of concentration, you could think of the root word, concentrate. Not like thinking, but when I think of concentrate or concentrated, I think of orange juice. So when you have orange juice concentrate, or it's in a condensed form, and then you add it to water later on. Oh, by the way, if you hear noises in the background, it's Kylie playing, so you might hear her every once in a while. Okay, let's get the official definition of concentration. Concentration is the measure of how much solute is dissolved in a specific amount of solvent or solution. And here's the two examples between these two. There's a lot of tea dissolved in this beaker and not a lot of tea dissolved in this beaker. So this one is more concentrated. And this one is weaker. There are these 5 ways that we're going to learn how to calculate concentration, but today we're just going to focus on those 3. The first one is percent by mass. Concentration in percent by mass is expressed as a percent of a ratio measured amount of solute to a measured amount of solution. So it's a percentage. You're going to do the mass of the part you're looking for over the total mass times 100. This is very important, this total mass. Don't get confused. Sometimes you'll have to calculate this total mass. So usually it's the percent of a solute in a solution or the solvent in a solution. And we'll do an example on the next page. Write the formula down. Okay, here's our example. Your aquarium needs to have a concentration similar to ocean water. To do this, it must contain 3.6 grams of salt per 100 grams of water. What is the percent by mass of salt in the water? So we're going to find the percent of this. So we're going to have the mass of NaCl over the total mass times 100. All right. Our NaCl is 3.6 grams over the total. So we have to add these two together and we get 103.6 grams and multiply by 100. Okay, calculate that and then come back and see if you get the same answer as me. I got 3.47%. Those are pretty easy. The next problems are percent by volume. It's the same as percent by mass, but you're just working in volume. Usually used for solutions in which the solute and solvent are both liquids. So percent by volume equals the volume of the solute over the total volume. I'm going to change that. Total volume times 100. I didn't have an example prepared for this, so I'm going to write one down. Okay, so here I wrote a problem down. What is the percent by volume of 56 milliliters of ethanol dissolved in 284 of water? So we're going to do the percent, I should have told you, percent by volume of ethanol. So we're going to put ethanol, the volume of ethanol, over the total volume. So again, we have to add these two together. 340, and then we multiply this by 100, and what do we get? I got 16.5%. Okay, let's try the next type of problem. Molarity. Molarity is one of the most common ways to measure concentration, and I'm going to rewrite the formula for you. Molarity is abbreviated with a big M. It is molarity equals moles of solute over liters of solution. So you're going to need this equation because sometimes I'm going to give you molarity and liters and ask for moles, or sometimes I'll give you moles and molarity and ask for liters, or I'll give you these two and ask for this one. We're going to use it every way possible. Here's your first example. Calculate the molarity of a solution made by dissolving 23.4 grams of sodium sulfate in enough water to form 125 milliliters of solution. So, it doesn't say so outright, but sodium sulfate is your solute because it tells us we make this much solution. So those are the two things we know. So to find molarity, we have to be in moles per liter. This is grams right here, so we're going to have to convert that to moles. 23.4 grams of Na2SO4. Grams goes on bottom, and moles goes on top. And how many grams are in 1 mole? Remember, always. So get out your periodic table and add that up. I got 142.042. And then when you divide 23.4 by that, I got 0.165 moles. So I'm almost done. So I'm going to fill it in up here. 0.165 moles per liter. Now I'm in milliliters. So 125 milliliters, and there's 1,000 milliliters in 1 liter. So I would get 0.125, and that goes here. Okay, when you divide this, I got 1.32, and then we label it just with a big M, molarity. Let's try another one. Calculate the molarity of a solution made by dissolving 5 grams of glucose in sufficient water to form 100 milliliters of solution. So we're going to have to convert that 5 grams of glucose from grams of glucose to 1 mole of glucose. Okay, calculate the mass of glucose to put down here to make this conversion. Push pause. Okay, it's 180.156. Divide that and see what you get. I got 0.0278. That's a 7 right here, sorry. Moles. Okay, and then remember, molarity is moles of the solute over liters of solution. Sorry, Kylie's loud in the background. So that moles can go here, 0.0278 moles over, we need liters, we're in 100 milliliters, so 100 milliliters, there's 1,000 milliliters in 1 liter. If you divide, you get 0.1 liters. That goes down here. So our molarity would be 0.278 molar. That's a decimal. Okay, let's try the next one. How many grams of Na2SO4 are required to make 0.35 liters of 0.5 molar Na2SO4? So I have molarity, I want to get to, and volume, and I want to get to grams. Well, I know that molarity is moles per liter. So I have this one, I have this one, I can get to moles, and then I'm going to have to convert from moles to grams. So let's do this part first. 0.5 molar equals moles times 0.35 liters. So 0.350 is on bottom. It's dividing. The opposite of dividing is multiplying. And what you do to one side, oops, sorry, you must do to the other. So what do you get for your moles? I got 0.175 moles. Okay, I'm going to move this over this way, and I'm going to start fresh, or up. Okay, so we know this is sodium sulfate, so 0.175 moles of Na2SO4. How do we get from moles to grams? Well, moles is on top, moles goes on bottom, and grams is going to go on top. And it's always how many grams are in 1 mole, so we have to add up that. And we did it just a few slides ago. If you look up in your notes, you should already have this mass written down. And it is 142.042. And then you'll multiply and get your answer. I got 24.86 grams of Na2SO4. So now you know how to do several types of these problems. Just take your time and do your homework.